Uplink profile is simple. Did you say something?
No, no.
Okay. So uplink profile is basically it tells to the NSX-T from a host. We have NIC card, right?
Yeah.
Server will have a NIC card, maybe a 2-port NIC card or 4-port NIC card or whatever it is. So this uplink profile will tell to NSX-T how these NIC should be used for the NSX-T functionality, or the different parameters we will be setting to the NIC cards will be specified, because this is the ports which is getting connected to your physical switches. Okay, so we are going to define those details. So on the GUI, once you log in, system, then fabric and profiles. So we have different type of profiles. You can see here, you have uplink profile, NIOC profile, edge cluster profile, edge bridge profile. So there are lot many. Okay. So what we are going to see now is uplink profile. Under uplink profile, you will have few uplink profiles already created. It is built in, right? When you deploy the NSXT manager. So if you want to create additional uplink profiles, then you will click on add. You click on add, you will get this pop-up window. So here it's asking for a name. Then if you want to use a lag, what is lag?
Link aggregation.
Link aggregation.
Great.
Right? If you are using a LACP protocol for bundling multiple links of your server, then that you will specify here. Okay. Otherwise, if you are using normal teaming, then that you will specify here. Okay. Then here you
So
are
this,
saying
yeah, yeah, this uplink profile for this north-south connectivity towards
no,
um,
no, 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 no.
leaf.
Towards the leaf,
Oh,
yes. Towards the leaf.
towards the leaf.
Nodes,
Uh,
nodes are connected to the switches. So these
switches.
links, how it should be used?
Okay, it's for then. In that case, it's a north-south connectivity, right?
No, it is just a physical connectivity. North, south,
Uh-huh.
or east, west is based on what is the traffic which is flowing in the network.
Mm-hmm.
Okay, so
Then,
if
uh,
from the same node, if you are sending a traffic to other server, it is east, west. From the same
mm.
node, if you are sending a
Mm.
traffic to outside world, that is north, south. This is a traffic what we
Oh,
are calling. The flow of data is what we call it as east, west traffic or north, south traffic.
so this uplink port can be used for both.
For both,
Can be
both.
either north-south or can be both. It will be used for
Yes.
east-west traffic also. It's
Same
north-south
nick.
traffic.
Same nick will be
Uh-huh.
sending or receiving east-west traffic or north-south traffic.
Okay. So this lag is for teaming, right? This NICA
Yes.
teaming or specific
It is for NICAD teaming. If
teaming.
you have a LACP
Uh,
configured on the switch side, then on the
uh,
node side, you will configure this lag.
okay.
Lag configuration will support LACP protocol.
Mm, 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 mm,
Okay, so if switch side is LACP, then this side also it should be LACP. Otherwise, link will
mm.
not come up.
Okay.
Okay. Now we are specifying something called a transport VLAN. What is transport VLAN?
Mm,
See, yesterday I told you from the nodes, inside the node we have multiple VMs, right?
mm, mm,
And these all VMs, when it reaches to the node, so that is node means server, the servers are acting as VTEP
mm.
or TEP.
Server.
So what is mean by
Server.
VTEP? Tell me.
It is a virtual tunnel endpoint, right? So,
Tunnel endpoint, right?
tunnel endpoint. Mm,
So we
mm,
have TEP. The
mm.
servers are acting as TEP. Every server is a TEP. So what he does, he is doing VXLAN encapsulation and decapsulation,
mm, mm, mm,
right?
Okay.
So
Yeah.
the normal Ethernet traffic, when it reaches the
mm,
node, this Ethernet traffic is getting a additional header of VXLAN.
mm,
Then on top of that, we are getting a Ethernet header added,
mm,
and it is going out to your next layer switch. If it
mm,
is access AG, it is going to the AG switches. If it is a spine leaf, it is traffic will be forwarded to spine leaf, spine switches. Whatever it is, what is the
mm,
traffic? Outer header is Ethernet. Ethernet means
mm,
it is going as a normal packet which where the VXLAN is not visible to anyone. So if we are sending
mm,
Ethernet traffic, this will be part of any VLAN.
mm, mm,
So
mm,
through which
mm.
VLAN I will send this packet or this frame. So to
Okay.
carry the encapsulated right, VXLAN encapsulated frame, we need to send it through some VLAN. Then only it will go to the other side. So
Mm,
which VLAN will carry this VXLAN encapsulated traffic to other devices is what we are specifying in transport VLAN. Simply, it says
mm,
which VLAN we will use to transport our
mm.
encapsulated traffic from one device to another device.
Okay. This again, it's east-west traffic.
Now, again, I'm telling east-west is the traffic which is flowing. Okay. So
Mm,
this VLAN,
mm,
he will carry the traffic. He don't know whether it is a east-west or north-south.
mm.
Both traffic can go through this VLAN.
Okay. Okay.
Okay.
From server to server, the VXLAN tunnel will be get established, and then the
Using this
traffic will
VLAN,
be
right? The tunnel is
using
getting
this way.
established, right? So how the tunnel is
Uh,
forming? Those tunnel traffic
mm.
is passing through this VLAN, 113 VLAN.
113 VLAN. 113. Okay.
Yeah, this
So
one.
again, this tunnel will go via leaf switch, or how it will be? This tunnel.
Tunnel will be going, see, whatever you have physical path, through that only
Mm,
your
mm,
traffic can go, whether it is tunnel or
mm,
your user traffic or
mm,
whatever it is. So how
mm,
is the physical
mm, mm,
connectivity you have? It is
mm,
like this, right? You have connection from here to here, here to here, here to here. So if your use traffic is going from here to this VM, then this will use
mm,
this path. Or
mm.
alternatively, it can use this path also.
Mm.
If it is
Okay.
east-west.
Mm.
If it is north-south, again it is using the same path, but it will go to edge node. From the edge node, it will go outside
So in that case, this VLAN need to be get configured in the leaf switch also.
on the leaf switches also. Yes.
Okay. Yeah.
Okay. If you don't know more in
Mm.
detail about spine leaf, don't think about spine leaf and complex it. Think about access ag network. That is simple, easy to understand.
Access. Yeah. Yeah. Correct. 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 Correct.
Okay.
Access.
Right. So
Some switch.
yeah. So
Yeah.
so
Mm.
in this case, this
Mm.
113 VLAN
Mm.
must be configured on all your physical switches. Your whole
Mm.
network
Mm.
infrastructure must be
Mm.
configured with 113. That is the prerequisite.
Mm. Transport VLAN. Okay.
Yes, transport VLAN must be configured on your physical infrastructure, and that VLAN you need to give it in NSXT. If I
Okay. Okay.
say, if I tell to NSXT, you use 113 VLAN, and if the network
Mm.
don't have 113 VLAN, then what will happen? NSXT
Yeah.
cannot send the
Forget.
traffic, right?
Yeah.
So this is the only one VLAN you need in your physical infrastructure for right sending your traffic. Doesn't matter how many subnet you have, how many IP group you have, doesn't matter. Just one VLAN is enough on your physical infrastructure. Clear? So we are
Yeah.
specifying what is our transport VLAN we want to use for sending the encapsulated traffic. Then we are saying what is my MTU? What is MTU?
Yeah. Maximum transmission rate.
Maximum transmission unit. That means
Okay.
what is the maximum size of a frame which can be passed through your network.
Mm.
Okay. Normally it is 1518, including your header.
Mm.
1500 byte is your actual frame, and on top of that 18 bytes of header will be there. So total a frame can have 1518 byte. But now what is happening here? We have a additional VXLAN header is getting added. We have a
Mm.
additional Ethernet header is getting added. So this will not be the default size, right?
Mm.
So the frame size is increasing more than 1518.
Mm.
That is the reason we are telling to NSXT that okay, you can the frame size can be up to 1600 byte. That means again your physical network infrastructure must be enabled with MDU as 1600. So when NSXT sends 1600 byte of data, your switch also should know that okay, I need to support this big size of frame, otherwise the frames will be dropped.
Okay.
Okay, so two configuration on your network infrastructure. One, you need to set your MTU. Second, you need to configure one VLAN for transport purpose. Clear?
So the VTEP IP that will be on a VXLAN header, right? The VTEP IP on the
VTEP
server.
IP address will be on your VXLAN header.
VXLAN header. Okay.
Or we can say, so it's not exactly like that. So how we tell is, this is your original Ethernet.
Mm.
Then your VXLAN header is getting added.
Mm.
Then your UDP header. Then
Mm.
your IP header. Then your Ethernet header. This is the actual. If I see I inside, this will be the structure. So this IP address will be your tunnel source IP and tunnel destination IP. That is your VTEP IP
Mm.
addresses. Source VTEP and
Okay.
destination VTEP.
Oh,
Clear.
okay.
And
That
inside
will
this
be.
Ethernet, there will be IP
Yeah.
header. This IP header will have the source and destination, actual source and destination who is communicating this VM IP address and this VM IP address, source device IP address and destination IP address.
Okay. Okay. Inside VM IP will be there. It is
Inside the
encapsulated
VXLAN
inside.
header. And this is for your
VM.
VXLAN purpose. So source and destination will be your TEP devices.
Right. Okay. Then VTEP IP. What is
Clear?
that Ethernet one? The top one?
This one.
Yes, yes, yes.
This is the Ethernet frame. By looking into this, see,
Uh,
once it is encapsulated,
mm.
where the traffic should go? It should go to the other tunnel endpoint, right?
Tunnel endpoint
Destination.
MAC address.
This step MAC address will be there in the Ethernet
Mm.
header. Source will be this step MAC address. Destination will be this step MAC address. Here in this Ethernet header, source will be the source VM's IP address, and destination MAC address will be destination VM's IP address. Sorry, MAC address.
Okay, okay.
Is that clear?
Yes. So before that, ARP will be get resolved, right? Then only
Yes.
it will send the packet. Okay,
Yes.
okay,
Yes.
got it. Yeah, thank you. Ethernet
Those are
IP.
normal. Whatever is happening in the normal networking, those all activities are
Mm.
required here also. All right. So now
One
we
minute,
specify all these.
I'm writing it. Just a minute.
Okay. Okay.
Yeah, yeah, you can go ahead.
Okay. So once we give all these parameters, then we will say add. When you click on add, that particular uplink port group will be added here. Okay. So you will get a
Mm.
additional entry. And this port group, this uplink profile can be used when we configure our host preparation, when we do our host preparation. So two things we did now. One, we define the transport zones. Two type of transport zone. One is overlay transport zone and another one is VLAN transport zone. Right? That we defined.
Okay.
Second, we created a uplink profile. This will tell how the NIC cards of your node need to be used for your NSX-T purpose. Right?
Yeah.
So there are two type of, yeah, I think quotation.
Two type of
Two type
any
of
question?
transport zone. One is VLAN transport zone. What is the other one?
Overlay transport zone.
Overlay.
Overlay transport
So
zone is for your VXLAN traffic and VLAN transport zone is for your VLAN traffic.
VLAN transport zone for VLAN traffic and
Overlay
overlay
transport zone
transport.
for your VXLAN encapsulated traffic.
Okay. So right now we discuss, right? It is a VLAN
Trans-
transport zone.
transport zone was yesterday's topic. Today what we
Understood.
discussed is only the uplink
Transport
profile.
VLAN. Okay, okay, okay. Okay,
What we
okay.
discussed now is transport VLAN, not transport
VLAN
zone.
zone. Okay.
Any question?
Koteshwar Rao asking.
No, nothing from my side.
Okay, okay.
Okay. All right. Now I told you our ESXi servers are acting as steps who is doing the encapsulation and decapsulation. And just in previous slide, I told you in the VXLAN header, this is your original Ethernet, then VXLAN header will be added, then UDP header, then IP header, then Ethernet. Right. So in this IP header, what is the source and destination? The source TEP device's IP address and destination IP address will be destination TEP device's IP address. So that means inside your host, when he do the encapsulation decapsulation, he is using a IP address which is actually doing that encapsulation forwarding the traffic, right? So what is that IP address? From where they will get the IP address? That also we need to define. So that is what we define using our IP pools. Okay, so till now what we configured is in system tab. Now it's IP address configuration. It is networking part, right? So we'll go to the networking tab. Inside that bottom, we will see IP address pool. And we have here IP address pool and IP address block. So you select IP address pool and click on add IP pool. So it will ask for a name and here it will be 0 when you do for the first time. If you click on that, you will get this new window open. So here you can add your IP address. Okay, so you can define your IP address range. Then once you say OK, you can save it here. Okay, simply here we are saying a range of IP address which can be assigned to these devices when NSXT manager does the host preparation. So when he install the modules to this server, he will assign one IP address also to him. From where? From this IP pool, whatever we are configuring here. Simple, right? Any question?
Yeah, for there are some individuals, right? Like Ethernet, IP, UDP. So for them, the IP pool can be, I mean, these can be assigned to some IPs, right? I mean,
Your
yeah.
Ethernet is layer 2.
Okay.
Packet is your layer 3.
Okay.
Segment, that is your TCP or UDP, that is your layer 4. Okay.
Okay.
So only your layer 3 need IP address. This is your port number. This is your MAC address.
Okay.
So once you prepare your host, you need an IP address for communication, for the TEP functionality. So what NSXT manager will do, he will pick one IP address from this subnet and he will allocate it to this step. When he do next host preparation, he'll pick another IP address and he will assign it. From the pool, he will assign one IP address to each device.
Okay. Got it.
What is VMK port or VMK NIC? What is VMNIC? What is VMK NIC?
VMNIC is nothing but virtual machine NIC. I mean, virtual NIC of a VM.
Virtual NIC of a VM. What is VMK NIC?
There is a uplink NIC.
Hmm? You have a server configured with ESXi or installed with ESXi. How do you access that server from your PC? This is your PC, you are sitting here. This is your
Okay.
switch. So your PC is connected to the switch and switch is connected to the server and server have ESXi installed. How do you access this ESXi in this PC?
I think our diagram is okay. Yes, XI.